So we're working with Bob and David and Greg on the 5G New Thinking project. So, all right, we've been focused on making the software tools that help streamline the process, so that it's not just a one-off when we go and build a network at Orkney, but this kind of approach and set of tools that we're making in 5G New Thinking can be replicated around the UK to continue to extend rural access. So what I'm going to in particular talk about today is a tool that we've been making to help streamline the SAL, the shared access licenses that Martin talked about a moment ago, and also try to position us in a way in which we can help enable the fully automated DSA ecosystem that builds on the existing SAL regulations. So we're going to talk about challenges with that and how we're going to end up getting there. So Martin has talked a little bit about this already, so I'm not going to talk about shared access licenses. I've got a pretty chart on the left in which you can see how they're distributed around the UK. But there are a number of things to take away from this in terms of shared access licenses, and that's it's got a number of nice properties for enabling spectrum sharing. So first, the bands that were chosen coincide with 3GPP bands, whether for 4G or 5G. So that helps address some of the spectrum sharing ecosystem problems in which there are devices that are there. You still have other issues that if you want to go to a fully automated DSA solution, then you still got to bootstrap the processes onto that equipment to support the DSA regs. But there's at least underlying equipment there that folks like Greg are using in the bands up in Orkney and elsewhere. Second, there's been fairly good adoption of the SAL. So just under 1,300 have been deployed. That's quite a number of over basically a year and a half of operation. And it's currently a manual process in which you fill out an application and mail it off to Ofcom. And that takes about 4 weeks turnaround, which is very good for having Ofcom engineers go and review and then do calculations and get back to you. But that's fairly long and it's sometimes iterative. So having David's kind of network planning process in which things change, and then if you come back 4 weeks later and you can't do the network plans that you were expecting on, now you've got another 4 weeks before you can start iterating through, and that can really start adding up and slow down deployments, and that becomes a real problem if you're trying to do quick pop-up sites as well for events or some such. And then there's a general concern that how is this going to scale indefinitely as it continues to grow in use? So there's already been interest expressed from industry and from Ofcom that can we automate the existing process, and can we do it in a way that would help transition to a fully automated DSA solution. That's kind of what I'm going to talk about today. When you look at automating DSA, there's a number of challenges that have to be overcome, kind of inherent to any band. And the first is, I have a colleague calls it the chicken and egg problem. I call it the ecosystem bootstrapping problem, which is how do you get there if everybody has to be implementing the same thing at the same time? So that can be in terms of everybody has to have new equipment for a band that was never available before. That's one of the challenges with TV white space. It would also be how do you go about getting everybody to implement the new protocols on their network management solutions to interface with whatever DSA automated controller is there. And fundamentally, that's challenge with any market. Any new market, how do you actually build technology for a market that doesn't exist yet? How do you actually go out and try to deploy things if you don't have technology to do it? It gets overcome. It was worked through in CDRS, but that took a good bit of effort. But it's something to be aware of as you're trying to pop up to a full DSA. How do you get there in a way that doesn't create an insurmountable hurdle for the folks to augment the existing technologies that are there? Second is that with spectrum sharing, that's where there is spectrum to be shared, there tends to not be population. So it's possible to go off and get a hold of MNO spectrum in the Orkneys because there's not as much build out there because there's not as much population there. The flip side is if you end up making your regs such that it's overly protective, then you end up only getting access in rural areas, and then it's harder to get as much build out. So that's kind of one of the reasons we think that we see the difference between LAL adoption and SAL adoption, is that there's limited availability for LALs. It was also a big fight in CBRS to ensure that the coastal areas were still available for access, because otherwise the ban would have never taken off. Finally, there's a tension between achieving scale and then optimizing for your local conditions. So you can imagine fairly easily that trying to what makes sense in the Highlands of Scotland in terms of probably having very few nearby networks that you can interfere with would lead to a different set of rules that you would want to have in place, as opposed to a dense London area where you have to be concerned with significant interference to other networks if something happens to go wrong. So how do you go about balancing having something that's scale to help support the technology evolution, and how do you go about balancing that against optimizing for what makes sense for local conditions, so you don't have really rural areas having to operate under the same burden that a denser area may have. So here's our insights that we had that we're trying to work around the problem. If you read too many online web pages, here's this one weird trick that we're doing to solve all the world's problems. But really four things, but interlocked. And the first one's not a new insight necessarily, is that cloud-based software allows you to do scale and to do customization at the same time. That's what Netflix and Amazon do. And that's what we've done a number of times on other efforts in which we're able to dynamically drop in hyper-local regulations and hyper-local policies that allow local optimizations and customizations when there's a need for that. And I'll note that across the different domains, the GIS and RF modeling aspects are kind of known commodities at this point, and it can be done in the cloud, and so on TV white spaces, that part, and you see it in CBRS and other places. But if you're doing these kind of changes and you have a protocol to communicate with the devices, then ultimately those devices don't have to be exposed to that complexity or changes that are going on in the cloud. They just have to know that this is the spectrum that's available to them now. The next point or insight is that most of these protocols are built off of REST, which has a number of nice properties, but it's also, in addition to communicating with devices, it's also the underlying technology for web pages and client server arrangements, which means that conceptually, instead of having to have all devices day one communicating with this protocol, you could have people logging into the web pages and updating their spectrum usage. And we call that automated to the engineer as opposed to automated to the device. And you could have both of these operating side by side, because to the spectrum manager, it doesn't really care if it was ultimately originated from an engineer or a device, as long as you trust both the device and the engineer to actually do what they say they're going to be doing in terms of network configuration. So the immediate challenge that come to your mind off of that is that I don't want to be sitting on a web page clicking constantly saying, yes, I'm still using the network, as you have with a bunch of these protocols, periodic message called a heartbeat. And you can, going back to that Scottish Highlands versus urban London distinction, you can conceive that you'll need to have a more frequent touch point in urban areas than you do out in rural areas, at least as network density grows or deployment density grows. But you could have these two co-systems side by side, different bands, different areas based off of the customization. And getting finally to the last point there is that as the SAL regs are currently structured, Ofcom has reserved the right to go and tell any of the manually configured networks approved under the SAL regs that within the next month, we need you to modify service. So it would be perhaps a reasonable thing to have a monthly touch point with the manually operated networks under the same set of rules, same set of protocols, so you can start having the same solution manage both something under the existing rules and then something under a fully automated device, so you could have both the existing regs and future DSA operating side by side within the same ecosystem. And then since you can do customization inside the Spectrum controller, you can then shift the ecosystem over time, so you don't have to have a giant step all at once to transition into a fully automated DSA ecosystem. So what we've built, I'm going to kind of layer this in over a few slides, is we're starting from, let's take the fully manual existing process in which Greg or David goes and applies for an SAL application for the network that they're planning to do. So it comes across via email, a little stick figure Ofcom engineer will go off and look at the application. There's a number of different nicely published rules for how they're going to go about determining if the access is allowable. They pull in data from that they're managing, and also some other public databases that say, is this a rural area or urban area, to determine that medium versus low power distinction that Martin mentioned. That's kind of what's here now. So what you can do is you can replicate those same processes, the GIS and RF calculations and so forth, make use of the Ofcom data and the public databases. And then you could set up a web service that, rather than having to wait 4 weeks to figure out that something is feasible or not, you can basically, as quickly as you can enter in the data that go in the application, we can do the calculation and give you feedback on that. So we call that kind of the augmented manual process. It's still ultimately being approved by the Ofcom engineers, and approval is ultimately 4 weeks, but you can start iterating quickly before you actually make that application to try to figure out where Spectrum is actually available and how might you want to tweak your site so that you can go through David's many loops of network planning and design on a minute-by-minute basis instead of a month-by-month basis. All right, so after that, you could go ahead and fully streamline the manual process, so you can have a more extensive user interface that goes through and makes the inquiry, and then they can go ahead and if Ofcom was so approved, or if this was actually embedded inside of Ofcom itself, give an instantaneous response, say, yay, verily, you're approved for this, go forward and deploy. So now you've cut down the whole cycle down to less than a minute. So giving the inquiry and the natural license response. So if you want to go from there to a fully automated solution, then you could have the same kind of protocols coming across it that make that request. That's then saying every time check back in at this certain interval to make certain that nothing's changed, that no incumbents have popped up. We didn't go through and change the regs to allow low Earth orbit satellites in that need more frequent protections. And then that can be also done to the device, or it can be done through a device proxy, where you've got many different devices that are being managed at once. And that's kind of the more full DSA solution at that point. So what that means is, after you get this basic piece up and working down here, because this is all REST interfaces, and then in effect checking about Spectrum, making a grant request, and then renewing the grant request, is all conceptually part of the same protocol. You can use that same protocol across these widely disparate use cases, and allow someone who's operating still under the original streamlined manual process, someone who's going through the automated engineer process, or a full DSA to be operating side by side. You could have Ofcom as need be pop in here, adjust rules. But the upshot is, rather than having to have this giant step from existing regs to to a fully automated DSA, you can do this as the market itself evolves, and you don't have to deal with the bootstrapping problem, and you get the advantages of local customization and just much greater flexibility, and all ultimately quicker, faster, easier access to share spectrum. So I'm going to flip over real quickly and show you one aspect of this. We've actually got all this kind of prototype if people want to see stuff offline, but I'll show you something that's going to be publicly available soon after we get through a quick little security audit to make certain that we're not going awry of any privacy regs, in which you can do this augmented manual process in which we've got a service that will tell you, look at the application that you're planning more or less, and give you instant feedback on if we think it'll be viable, and then things that you might want to do for alternate configurations. So I'm going to tab over to that, I think. All right, so this is, you can actually go to that website. It's a public website. Can't get in, but we'll be letting folks get in soon. So let's do a quick inquiry onto locations. Pick a spot up in the Wilton Islands. So that's about that far north and about that far west. And on the actual application, it's looking for British grid reference and eastern and northern. So you don't need it for this at the point, but it's being automatically generated in the background. You can see that quick note where it's telling you that where you chosen happens to be in a rural area. And then it'll actually guide you through the options that you have as you're picking these in terms of which bands you're allowed to have the different kind of configurations and the bandwidths available for that band, and tell you how much power you can't get. If I pick too high of an antenna gain, it'll tell me no, can't do that. Let's pick some height above ground real quickly. I've entered the stuff. The SALs are renewable, so you don't actually have to put in a license duration, but if it's a short event, you can. The SALs support that, and you would actually get a smaller fee off of that. And so I just checked. I've got results back for what spectrum I could actually get for the location I chose. And if you actually wanted to know why you can't get as much power, you can go through and look and say, this is where there's a number of different existing fixed point-to-point links across the Orkney Islands that are using spectrum there that are keeping you from getting full access in those bands which are currently being used. So that is a tool that is up, and if you want to talk to us, we'll share something offline. It's going to be probably available soon. And this is part of that, back over, larger capability for getting us to a fully automated DSA, and then also streamlining the manual process. But everything from here down requires explicit coordination with Ofcom to make it happen. But the same software solution in the background helps you support all of these and will help us get to a fully automated DSA environment in the SAL bands. So that's my talk. Hopefully I came close on time. Bob, I'm going to hand it back over to you.
Okay, thank you, Jody. That was great. And if we'd been rehearsed, we could have got the right latitude, longitude for where we are in Loch Lomond today. But that was absolutely fantastic. And I hope that demonstrates some of the 5G new thinking endeavors. Is we're really looking forward. We're excited for, and we're also looking forward to these tools being available and just being another way of connecting rural and remote areas.